Okay, we're here today to talk about factoring and solving polynomial equations. In our book, it's section 6.4. On this first page here, on this first screen, I've got kind of the protocol for how to factor polynomials. And if you're going to solve a polynomial equation, you first want to get it in standard form that's equal to 0 with the exponents on the variables in descending order. And then once you get that equal to 0, then on the other side that's got all the terms in it, you need to be able to factor that polynomial. So we start out by learning how to factor the polynomial side of this equation that's equal to 0. So we're talking about the side that has all the terms. Well, the first thing you want to do is, anytime you're asked to factor something, you want to look for and take out a common factor. Okay? And then the second thing is that you look at how many terms you're left with. Now, after you take out a common factor, if you're left with a binomial, there's only 3 binomials that factor beyond taking out a common factor. Now, let me say this. Sometimes all you can do is take out a common factor. And so that's sometimes where you stop. But if after you take out a common factor, if you have a binomial and it matches one of these 3 special cases, the first one's the difference of 2 squares. Of course, that factors into a minus b times a plus b, and that's one that my students have seen already this year. New to our class is the sum of 2 cubes. It's another binomial that will factor, and that's going to factor into a plus b and parentheses, and then a squared minus ab plus b squared. And then the third one is what we call the difference of 2 cubes, and so that's going to factor into a minus b, a squared plus ab plus b squared. Now, one way I can always remember these is that the binomial that you're factoring, the first part of the factorization always sort of matches the bases and the signs between them. These are exponential numbers, so the base would be a and the b. So you see it's a minus b, and that's what we're factoring is a squared minus b squared. And the a plus b matches the a plus b here, and a minus b, it starts with a minus b. Now these two, the bottom two, well, let's just remember that there's only one negative, and since the sign has got to match what you start with in the plus, the first time you could use that negative would be over here. And of course, in the difference of 2 cubes, we already have the one negative used, so the other signs are positive. That's just how I remember it. Okay, if after you take out a common factor you're left with a trinomial, then my class factors that by the AC method. And if after you take out a common factor you have 4 terms left, then that is factored by grouping. Now, we haven't seen factoring by grouping yet, so we're going to start with that method, factoring polynomials that have 4 terms in them. Okay, so to factor by grouping, if the polynomial has 4 terms, we use the method called grouping to factor it. And here's how it goes. Okay, we'll start with example number 1 here. And didn't want to do that. Let's see. Let me change that so I get it. All right, there we go. All right, so move this up a little bit. Move it over. There we go. Have to probably widen this up a little bit here. Well, we're just going to have to go with that for right now. Okay, so here's our example, x cubed plus 3x squared plus 5x plus 15. So the first thing you want to do, if you're going to factor by groupings, you want to make sure that the middle sign, and I'm seeing that you cannot see that. I'm trying to adjust this so make sure that the middle sign is a plus. Okay. All right, moving it back to this. In fact, I think I can solve that. Hang on. Okay, I think I got my borders straight now. I think you're able to view the entire screen that I've got here. So we want to make sure that the middle sign is plus. If it's not, we change that to a negative to plus or minus. So we know that for one subtraction sign, we could have a double sign plus a minus. Okay, these are basically equivalent. So if that's a minus sign here, we change it to plus a negative. Okay? And the reason that we do that is because the next step is to put parentheses to make 2 binomials. You can always put parentheses around a plus sign and not change any values of the the term or the polynomial that follows. But if it was a minus sign here and you put a parentheses, separated the minus from the 5, if that was a minus, then you'd end up really changing the sign of this 15 here, and you don't want to do that. So if it's got to be a plus before we put in the parentheses, we put in parentheses, creating two binomials. And then what you do, step 3, is to take out a common factor from each binomial. So in this one on the left here, we notice that both of these have x, and the smallest power of each of these is to the second power. So that's the common factor. So when we take x squared out of x cubed, we're left with x to the first. When we take x squared out of 3x squared, we're just left with the 3. Now here, we factor out a 5, because a 5 is a factor of both of these, so the 5 comes out, and we're left with x plus 3 here. Now you'll notice that both of these binomials are matching. Okay, that has to happen. I think I say that in the next screen. Let me see. Okay, so if the binomials match, and of course we can see that once we took out the common factor, what was left was the same binomial, x plus 3. Then it does factor. If these did not match, then we would just conclude that you could not factor it by grouping, but they do. Now I'll say this, sometimes you can rearrange them and they'll factor, but for the most part that's going to be true. Okay, and then so what you want to do is then you want to look at this as a common factor, and basically what we're going to do is we're going to imagine parentheses around the entire thing, and we take these two out, they become 1 on the outside, and then you put this parentheses closes in, and you get x squared plus 5 times the binomial x plus 3, and that's how you factor by grouping. Okay, let's try one. Factor this by grouping. Okay, well this is what you should have done. First thing, we're going to check to make sure that's a plus, and it is. If it's a plus, we can put parentheses around it and not change any values, and we make our two binomials. And then we look at the first one. The common factor is x squared. X squared comes out. Here it is on the outside. We're left with x minus 2 on the inside. And in this one, the common factor is 3. The 3 comes out, and we're left with x minus 2. I see these are the same. I factor them out, and I'm left with a binomial with x squared plus 3 in it, and that binomial that I just factored out, x minus 2. Okay, here's another example. Let's take a look at this one. This time the sign in the middle is not plus, so the first thing I'm going to do is going to change that to add the opposite. And I'm going to very carefully put my parentheses between those two signs. Now you need to do that. Because algebraically you can't put a parentheses around a negative. Now every time we change this from minus to add a negative, then what we factor out of this has got to be a negative. Now what I want to remind you of is that when you multiply by negatives, signs always change, and when you factor negative out, signs have to change. We say they change back. Okay, looking at this first one, then x squared is a common factor. We take x squared out, we're left with x plus 1. Now when you factor all of something out, then the understood coefficient of 1, and I sort of dotted in to say it's really there but you don't see it. Once you take the x squared off of that, then that 1 appears. And over here, I'm going to forget this as a plus, and I'm just going to write down the sign of what I'm factoring out. I'm factoring out negative 5. Well, with that plus, it would be plus a negative, and of course the 1 sign for plus and negative is really minus. So taking out minus 5, and what's left, now this was negative, now it turns to be positive x, and this was negative 5, and of course it's negative 5 times 1, isn't it? When I take the negative 5 out, I have positive 1 left. Now here's what you can always do. If you're not sure you did that sign correctly, just distribute that back and see if you get what you started with. What's negative 5 times x? Negative 5x. What's negative 5 times positive 1? Negative 5. So working backwards, it appears that we did this correctly. All right, now we notice that these are the same binomial, so we pull that out and we put parentheses around what's left. It's x squared minus 5 times x plus 1. Now, this the directions, I didn't write them up here, but it would be factor. And when we say factor, we really mean factor completely. And I noticed this x squared and a minus here, and so that made me think about on that first screen where we had the difference of two squares. Well, x squared is a perfect square. Any variable to an even power is a perfect square, but 5 is not. So this had a chance at factoring through through the x squared and the minus, but when I got to the 5, I realized it wouldn't factor. Now, if that was a 25, yeah, it would factor some more, and we'd have more work to do, but this time we're done. Okay, go ahead and give this one a try. Okay, well, the first thing we did was change that negative to plus and a minus, and we carefully put our parentheses separating those two signs. The negative's inside, the plus is outside. You can always put parentheses around a plus sign, doesn't change any values. Common factor in the first one is x squared. We take it out and we're left with x plus 4. Common factor in the second one, every time we change that to plus a negative, we factor out negative something. We're factoring out negative 3. Signs have to change. Negative change to positive, and I'm left with x. Negative change to positive, I'm left with 4. Back check it. Negative 3 times x, negative 3x, negative 3 times positive 4, negative 12. Done that correctly. Take out the common factor of parentheses x plus 4. It comes out. What's left, I put in parentheses x squared minus 3 times x plus 4. Okay, here's another example. Let's take a look at this one. Well, for starters, we check the sign. It is correct, and it's in descending order. I'm not saying that, but I do look at that. And we put the parentheses around the plus in the middle. And we look for a common factor. Always got to factor something out. Okay, in this first one, it's x squared. It's been that one every time, hasn't it? X squared has been the common factor. And what's left here is x minus 3. Okay, when I get over here, I don't see any common factor. But I do note that this is already matching. So could I factor out a positive 1 out of that? Would that be correct to say that it is itself times positive 1? So what we need to know is that even if they already match, and if you don't see a common factor, then you just factor out a 1. You can multiply by 1, you can factor out a 1 anytime you want to. Now we have the like binomials. We take them out and we're left with x squared plus 1 up here, and then that times the x minus 3. And neither of those factor. We're done. Give this one a try. Okay, well, we should have gotten x squared plus 1 times 2x plus 3. And if you have a question, I'll stop the video for you, and I'll answer your question in class. Okay? All right. Next example. Okay, so here we have the minus in the middle. It's in descending order. I don't see any common factor throughout the whole thing. We're supposed to be checking for that. I haven't said that, but that is something you have to check for. I'm going to change this to add the opposite. I'm going to put my parentheses between those two signs, and I'm going to take out the common factor. I promise the common factor is not always going to be x squared, but it seems like it has been on all of these. So it's x squared again. X squared comes out. What am I left with? X minus 2. Okay. And over here I'm going to factor out a negative 9. All right. So I factor out negative 9, I get x. Now remember, signs have to change, so that's got to be minus 2. And distribute it back to make sure it works. Negative 9 times negative 2 is positive 18. I get negative x. Okay. Then I take out the common factor binomial, and I'm left with x squared minus 9 times x minus 2. Now, if you remember, in the very first screen we talked about binomials that'll factor. Well, this binomial here is the difference of two squares. We'll go over this in more detail later, but this is x raised to the second power minus 3 raised to the second power. And our formula, so this is kind of stealing from the future here, is going to factor that into x minus 3 times x plus 3. And then we would annex this x minus 2. It's certainly part of the answer as well. So we'd have the product of 3 binomials that would give you this 4-term polynomial. Okay? You go ahead and give this one a try. Okay. Well, This is already a plus, so we put in our parentheses. In the first binomial, we'll take out our common factor. It's our old friend x squared again. It keeps popping up. We're left with x plus 2. And in the second one, I see that 3 is a common factor, so I factor out positive 3, and I'm left with x minus 2. Well, these have got to match. Are they matching right here? No, one is plus and one is minus. Guess what? Cannot be factored. At least not by the grouping method. Cannot be factored. Okay, sometimes that happens. All right, give this one a try. Okay, this one had a little different twist to it because if you'll notice that all of these terms have a common factor of 3. First thing you have to do when you're factoring is take out a common factor. So you take this 3 out, and from then on I'm working within a set of brackets that has a times 3 on the outside. So I take the 3 out and I get x cubed minus 4x squared minus x plus 4. I go ahead and change this to add the opposite, put the parentheses in, take out the common factor here. In this first binomial, the common factor is x squared. I'm left with x minus 4. And here I have to take out something, so I have to take out a 1. I take out a negative 1, and I have x, this is negative 1 here. I didn't factor it out. It just is negative 1. And then I take out the x minus 4, and I'm left with x squared minus 1. Now x squared minus 1, x squared is a perfect square, and so is 1 a perfect square. So that can go further. We have to watch out for those. This is x to the second, and this is 1 to the second, so it becomes x minus 1 times x plus 1. That's what this multiplies or factors into. Bring this down, bring the 3. Now we get rid of the brackets, and we get our final answer, 3 times x minus 1 times x plus 1 times x minus 4. Okay, factoring the sum and the difference of two cubes. Okay, so this is one of those things that we had at the beginning, and we've just showing you that again, these formulas. So here's what we want to do. Here's example 1, 2x cubed plus 16. First step is always take out a common factor. You can see both of these have a factor of 2 in it, and so it becomes 2 times x to the third plus 8. The second thing we want to do is identify what a and b are by making parentheses here, parentheses cubed plus parentheses cubed. I'll go ahead and put a step in between here. So I want to see if I can write it like in this form. I want to try to put it in this form. So is there something I can put here and cube and get x cubed? Yes, it's x. Is there a number I can put here and cube and get 8? Yes, 2. So here I'm writing them as the sum of two cubes. So I'm identifying what my a is up here and what my b is. It's going to be this. Okay? All right. Now, keeping in mind this is what the formula is for the sum of two cubes. Then we plug in those values for a and b. So our a was x, our b was 2, so it becomes x plus 2. It's a squared, so it's x squared. It's always minus. The formula takes care of the signs. And it's a times b, or it's 2 times x. And then it's always plus, and then b squared is 2 squared, or 4. And that's your answer. Don't forget the 2 that you took out at the beginning. That's got to be part of your answer. Go ahead and try this one. Okay, in this one we did have a common factor 2. We take the 2 out. We're left with x cubed plus 27. Then we try to factor the sum, try to look and see if this is the sum of two cubes. And of course, is there something I can cube and get x cubed? Yes, x cubed gives me x cubed, so x is my a. Is there some number I can cube and get 27? Yes, 3 cubed is 27, so 3 is my b. So it becomes a plus b, a squared minus a times b plus b squared, and the 2, don't forget the 2, the common factor we took out to start with. All right, you try this one. Okay, don't forget the other formula that we had at the beginning of this section. It was the difference of two cubes. Of course, it says that it factors into a minus b times the trinomial a squared plus ab plus b squared. Okay, so we take this, and I don't see a common factor, so nothing's coming out. I try to put it into the form of the difference of two cubes. The difference of two cubes. Is there a number I can cube and get x cubed? Yes, x cubed is x cubed. Revolutionary obvious there. Is there a number I can cube and get 27? Yes, 3 cubed gives me 27. So my a is x and my b is 3. So I'm identifying a and b. And now I'm just simply going to plug those numbers in up here. Remember, this formula takes care of the sign. You don't have to worry about signs. You just copy whatever sign's here. So it's going to be a minus b, or x minus 3. A squared is x squared this time. It's plus a times b, which is 3 times x, plus b squared, which is 3 squared, and that gives us 9. Okay, try this one. Okay, this time I hope you noticed there was a common factor, and it's not just a number. It's also, they both have x squared in them at least, so x is the smallest of the two powers of x in our terms. So we can take out x squared, and we also get a 2 out, and we're left with 8x cubed minus 125. Okay, stray mark here, don't pay any attention to that, please. Alright, so then the next thing we want to do is see if we can push or put this into this form, the difference of two cubes. So I got parentheses cubed minus parentheses cubed. And I want to ask myself, is there something I can put in here? It's got to be a number and a variable to wind up with 8x cubed. And of course we come up with 2x after thinking about that for just a moment. So it's 2x that goes in here because you got to cube both of them. So you cube the 2, you get 8, you cube the x, you get x cubed. And here, if you think about it, 5 times 5 is 25, and that times 5 is 125. So yes, if you cube 5, you get 125. So now that we've got this in this form, then we'll go ahead and we've identified what our a and our b are. And we go up here to our formula, and we plug in a and b. So it's and of course I've already brought down the common factor that I took out to start with. It'd be a mistake to not include that when the directions are to factor, and we're implying that the directions are factor. But back to this, it's going to be a times a minus b, which is 2x minus 5, a squared. Now when you take 2x and you square it, you got to square both of them. Square the 2 and get 4, square the x and get x squared. So it's 4x squared plus a times b is going to be 10x plus b squared is 25. Okay, factoring the difference two squares. Now we have already been over this, so we'll go through it pretty quickly. Here, example number 1, we got a common factor. We take a 3 out, we're left with x squared minus 25. Can we put that into the form of squared minus squared? Yes, you can put x here and square it and get x squared, and you can put 5 here. So this is our a and this is our b, so our answer is going to be the common factor 3. And it's a minus b times a plus b, or x plus 5. Okay. Try one. Okay, hoping you found the common factor in this one of 2. Once you take the 2 out, you get x squared minus 49. Can we write this as the difference of 2 squared? Well, x squared is x parentheses squared, and 49 is 7 squared. So yes, we can. Our a is x, our b is 7. We plug that into the formula. A squared minus b squared equals a minus b times a plus b. So for our problem, it's x minus 7 and x plus 7. There's our answer. Okay. All right, factoring a polynomial that is quadratic in type. Okay, example number 1. Now, we think of quadratic as being to the second power in like the difference of two squares, but the fact of the matter is that any variable to an even power could be viewed as something that's squared. For example, x to the 6 could be looked at as x cubed, and then that raised to the second power, because when you have a power raised to a power, you multiply them. So if it's even, certainly it's divisible by 2, and then you could show it as 2 times something. Okay, so with this one right here, then we want to look at it. We want to see if we can kind of squeeze it into this form right here. Okay, so is there something that we could square and get 81x to the 4th when we get through? Well, square 9, you get 81. And what do you square to get x to the 4th? But x squared. And what do you square to get 16? 4. Okay, so using the formula a squared minus b squared equals a minus b times a plus b. Going to have to memorize that. Okay, then we have 9x squared minus 4 times 9x squared plus 4. Okay, now when we say factor, it implies that we factor it completely. And this 9x squared minus 4, it's the difference of two squares itself. What can you square to get 9x squared? But 3x raised to the second power. So we have a responsibility to keep factoring this. And what do you square to get 4 but 2? So this part of it becomes 3x minus 2 times 3x plus 2. We have to apply that rule again, and then we would just annex this 9x squared plus 4. Now there's a common error made in Algebra 2 thinking that you could factor the sum of two squares. It just doesn't work. There's not two binomials that you can multiply together and get this. So don't try to factor the sum of two squares. It's not part of there's not a formula for it. Okay? All right, give this one a try. All right, this one, I don't see a common factor. I go straight to trying to putting it into the form of the difference of two squares. So I'm going to look at this, and so of course, what do you square to get 25 but 5? And what do you square to get x to the 4th, x squared? What do you square to get 36, 6? This is our a, this is our b. It's a minus b, a plus b. And when I look at this negative one here, really nothing, these are not the difference of two squares, so it would stop right there. That's the end of that problem. Okay, example 2. Now here's a trinomial, okay, and as I look at it, I know I factored trinomials by the AC method. We haven't done any of that during this lesson, but we have it in previous lessons. I see a common factor of 4x squared. I think I can take out all of that. Now what's left after I take out 4x squared but x to the 4th minus 5x squared plus 6. Okay, now quadratic in type is trinomials that are quadratic in type go along the same pattern of x squared plus x plus some constant here. Okay, now let me go ahead and put the exponent 1 in here. Okay, so what I want you to think about here is this. If we have a pattern that matches this pattern, what pattern am I referring to? The fact that if you start from the middle, the degree of this middle term, and you times it by 2, do you get this one right here? And is this no x at all? This back one is no x at all. See, you could look at quadratic as, well, the middle term, and then the middle term's degree times 2 is this one, and then no x at all. Well, this fits that pattern. Look at it. The middle term's x squared. It's x squared, and the squared times 2 is to the 4th, and there's no x over here. So if that's the case, if it follows that same pattern that I just kind of showed you over here, then we know we can factor this by the AC method. Of course, we're just going to take a quicker method than that. Now these would always factor into x something and x something plus or minus something over here. We knew there was an x up front. Of course, whatever's up front, remember, matches what's in the middle of the trinomial. These are both to the same power here, x to the 1st, x to the 1st. So when we have something that's quadratic in type, then when we can factor that trinomial like we factor any trinomial, except for the only difference is that the x up front is going to match whatever's in the middle. So if that was 4, it's 4, 2, and none, it's going to be x squared plus or minus something and x squared plus or minus something. Think backwards about multiplying these two binomials, to get this trinomial. The first thing you do would be first times first, so x squared times x squared equals x to the 4th. I mean, it's the only thing you can put there and have it to be the same and add up to be 4. 2 plus 2 is 4. Okay. Now from here, rather than doing the full AC method, we're just going to, since we know there's a 1 up front, so it's just x squared and x squared, we think about factors of 6 that add up to be -5. And so two numbers multiply to be positive 6 and add up to be -5, that would be -2 and -3. And of course, that's our factorization here. Be careful, make sure these are not the difference of two squares. Neither 2 nor 3 are perfect squares. So we'd basically be done except for adding our common factor that we took out from the start, which is the most common error in these problems. Okay, so there you go. There's your answer. Get you to try this one. Okay, hopefully you noticed that each of these terms had b, and b to the smallest power is 2, so b squared is the common factor. We take the b squared out and we're left with a squared minus 8ab plus 16b squared. Now we go to factor this. Well, this is quadratic. It started out looking like it wasn't, but once we took the common factor out, we have what we have is quadratic. Since it starts with 1a squared, I know in my binomials that there's going to be an a up front. It's going to be 1a and 1a. Now I'm thinking about factors of 16b squared. Well, let me mention this. The fact that there's a b squared at the end of this thing and a positive b in the middle, I know that there's going to be a b at the end of both of these binomials. That's the effects of having a double variable, one up front and one in back. If there's an a squared up front, there's going to be an a up front in the binomials. If there's a b squared in the back of the trinomial, there's going to be a b in the back of them. Now figure out what numbers we have between them. Factors of 16 that add up to be -8, that would be -4 and -4. So our binomials become a minus 4b times a minus 4b. And if you wanted to, you could write that as b squared times a minus 4b to the second power. That's also acceptable since these are the same factors. Okay? All right, now on to solving polynomial equations by factoring. So now we've learned how to factor all different kinds of polynomials. Now we're going to use that to solve polynomial equations. Well, the first thing you do with polynomial equations is to get them in standard form or get them equal to 0. You want to get it equal to 0. So you want to keep your leading coefficient positive as well. So since x to the 5th is the highest, 2 is positive on the left-hand side, I'll move everything from the right-hand side to the left-hand side. Now I'm just going to kind of perch that right between these two here, and then go ahead and add these sides. So here I'm just going to put it in the correct order, in descending order. And we have plus 24x. And now it's equal to 0. So step 1 is get it equal to 0. Step 2 is factor what you see. Now, what do you see here? Well, it's a trinomial. Looking for common factors, they all have x, and I think they all have 2, so I can take a 2x out. And I'm left inside with x to the 4th minus 7x squared, and that's going to be plus 12 equals 0. All right, I'm looking at this trinomial. It's not quadratic, but it is quadratic in type. The middle times 2 gives me this one. This one has none at all. I can factor this by the AC method, or we're just going to use the shortcut method is what I call it in class. Because if it starts with x to the 4th, then the two binomials would have to have a 1x squared up front. So we know that's going to be 1x squared. And now we're thinking about factors of 12 that add up to be -7. That'll be -3 and -4. Now hopefully your eyes are catching the fact that this is the difference of two squares. 4 is a perfect square. This one keeps factoring, so I'll take a line to do that. This one's going to stay the same because 3 is not a perfect square. Can't do anything with this one. But this is going to turn into, hopefully we can just now do this without doing the squared, parentheses squared minus parentheses squared. It's going to be x minus 2 and x plus 2. Okay? Now, what you're looking at now is a series of factors that multiply to be 0. Well, we know the zero product theorem tells us that the only way this can happen is if the individual factors equal 0. So at this point, the next step is after you factor, you get it in standard form, you factor it, now you set your factors equal to 0, and each one of these leads to a solution. So taking the factors and setting them equal to 0, and then we solve these equations. Well, this one's pretty easy to solve. You divide it by 2. 0 divided by anything except 0 is going to still be 0. So here you get x is equal to 0. That's one solution. Now this one's kind of different. If you remember when we have the squared term but we don't have the x to the first term, the best way to solve that is to isolate the x squared and take the square root of both sides. So that's what we do. We add 3 to both sides. And we get x squared equals positive 3. We take the square root of both sides, a little sloppy there, sorry, and you get x is equal to, and when you take the square root of both sides, you always have to start the number side with plus or minus the square root of 3. Now let me say we've got two different answers there, but it's kind of like in compact form there. I'm trying to make that look like an x. Well, let me just write another x right there. Okay, solving this one, we add 2 to both sides. We get x is equal to 2. Circling my answers. And we subtract 2 from both sides, and we get x is equal to -2. Okay, let's note how many solutions we found. 1, 2, 3, 4, 5. We found 5 solutions to this equation, and the degree of it is 5. Okay, so let me say something. That's the most number of solutions that you can find is the degree of it. Now, it doesn't mean it has that many, but it can have as many as 5. It can have fewer, but it can't have more than 5. Okay. All right, let's give a try. Let's let you try a problem. Give this one a try, please. Wow, what happened to the y that used to be there? That was a mistake. I changed it to x while you guys were working on this. So, poof, it's an x. Now we have common factor 2x that we take out. So you take a 2x out of here, you get x to the 4th, and then minus 9 here. We recognize x to the 4th minus 9 is the difference of two squares. This is an even power, and this is a perfect square number. So that's going to factor into x squared minus 3, x squared plus 3. Okay, none of those factor. We set our factors equal to 0 now. 2x is equal to 0. Divide by 2, we get x is 0. X squared minus 3 equals 0. We set this one equal to 0. We add 3 to both sides. We take the square root of both sides, and on the number side, we don't forget to write plus or minus. We get one solution here, 2 solutions here. And here we subtract 3 from both sides. We get x squared equals -3. We take the square root of both sides, plus or minus. The negative comes out as I. So we have plus or minus I square root of 3. 2 more solutions. Okay, so we got a total of 5. Only 3 of them are real, and 2 of them are imaginary. Okay, give this one a try. Okay, the first thing we want to do is get it equal to 0. X cubed is the highest. It's positive where it is. I'll bring the 18 over. Subtract 18 from both sides. You get x cubed plus 2x squared minus 9x minus 18 equals 0. All right, it's 4 terms. So we want to factor by grouping, and we're concerned that this is has to be a plus, so we changed it to add a negative, and then we put our parentheses in around the plus sign that we just created. All right. In the first one, we take out an x squared. We're left with x plus 2. In this one, we factor out -9, and we're left with x plus 2. We factor out the x plus 2, and we're left with x squared minus 9. X squared minus 9 is the difference of two squares. It's x to the second minus 3 to the second. So that factors into x minus 3 times x plus 3. Bring down the x plus 2 equals 0. We've got it all factored. We set our factors equal to 0. X minus 3 equals 0. Add 3, get x equals 3. X plus 3 equals 0, subtract 3 from both sides, you get x equals -3, and then x plus 2 equals 0, subtract 2 from both sides, you get x equals -2. 3 solutions, degrees 3, it's looking good. And let's try this one. Alright, getting the equation equal to 0, we subtract 28 from both sides. We get this 4-term polynomial on the left-hand side. We try to factor it by grouping. We look at the middle sign, it's minus, so we change it to plus and negative. We then put the parentheses in around the plus sign to create 2 binomials. In the first binomial, the common factor is x squared. We take it out, we're left with 3x plus 7. Anytime you change that to plus and negative, you always want to factor negative something out. We factor a -4 out, we get 3x plus 7. Back check to make sure the signs work, and they do. Take the x plus 7 out now, and you're left with x squared plus minus 4. Well, x squared minus 4 is the difference of two squares. You've got to keep factoring. And that factors into x minus 2, x plus 2, and then the x plus 7 comes, 3x plus 7 comes down, equals 0. It's all factored. Now we set our factors equal to 0, and solve those. We get x is 2, x is -2, and x is -7/3. Yes, there's no guarantee that you're going to get nice answers. You could get fraction answers. Okay, looks like that's the end of the video. I'll be making an assignment for the class, and thank you for watching.